Okay, so Unit 3, Lesson 4, finding and using slopes of lines. So we're kind of shifting gears into talking about parallel lines and perpendicular lines, but in terms of the XY coordinate grid. So some things to understand about slope. Slope is the rate of change of a line. So if we look at this diagram on the right, negative slope is represented by line J. That is a line that falls from left to right. That's a negative slope. Positive slope rises from left to right. A positive slope is represented by line K. Okay. Zero slope is represented by a horizontal line. And then undefined slope is represented by a vertical line. So that is line N. So the different types of slopes tell us different types of things about lines. So if we are going to find slope in the coordinate plane, I want to find the slope of line A. So I'm going to use red to do that. So that's this line right here. And this line contains the point 46 and the point 02. So if you remember from last year, slope is y2 minus y1 over x2 minus x1. So I can find this slope two different ways. What I'm going to do is I'm going to take 6 minus 2 on the top, and then I'm going to take 4 minus 0 on the bottom. So that slope becomes 4 over 4. The slope of line A is just 1. You could count the slope. You could count. You go up 1, 2, 3, 4. Right 1, 2, 3, 4. Rise over run 4 over 4, which is just 1. The next line I'm going to look at is line C. I'm going to use blue for line C. So this is line C. Line C has these 2 points, 4, 6 and 0, 6. So if I'm doing y2 minus y1, I would take 6 minus 6. And then I would take 4 minus 0, x2 minus x1. So this becomes 0 over 4. 0 divided by 4 is 0. And that connects to the diagram at the top. Horizontal lines have a slope of 0. So moving ahead, I'm going to erase my mess here. And then I'm going to have you guys pause the video, work through the first couple guided practice problems, and then check in with me once you resume the video. Okay, so these slopes. Line B, I wrote out the 2 points I see that are on line B. I took 3 minus 6 over 7 minus 4. Negative 3 divided by positive 3 is negative 1. Line D, 0.46, 0.40. I got 0 minus 6 over 4 minus 4. That became negative 6 over 0. If you punch that into a calculator, it will spit back to you undefined as the slope. And an undefined slope creates a vertical line. So a couple things to know about the slopes of parallel lines. Two non-vertical lines are parallel if and only if they have the same slope. So two lines are parallel if they have the same slope. And I see a typo, apologize. Lines, that should be lines. Any two vertical lines are parallel, just like any two horizontal lines are parallel. And then perpendicular lines, this is important. Perpendicular lines are two non-vertical lines that cross at a 90-degree angle. Perpendicular slopes, I want you to understand, are opposite reciprocals of each other. So opposite meaning opposite sign. One is negative, the other is positive. Reciprocals, I showed this. The reciprocal of 2 is 1/2. So the opposite reciprocal of 2 is negative 1/2. Just like the opposite reciprocal of negative 3/7 is positive 7/3. So opposite reciprocals. So we are going to apply that in example 2. Find the slope of each line, find out which lines are parallel. So K1 is the line to the left the most. So I would take these 2 points, -4, -4, -6, -3, -1. So I would take -6 minus -1 over -4 minus -3. So what that causes, this becomes -5 over -1. So K1 has a slope of 5. K2 has the points 2, 2, and 1, -4. So I would take -4 minus 2 over 1 minus 2. So that slope becomes -6 over -1. So the slope of K2 is 6. So K1 and K2 already are not parallel. They have different slopes. And then finally K3, it's the point 4, 2 and 3, -3. So I would take -3 minus 2 over 3 minus 4, which is -5 over -1. That slope is 5. So the lines that are parallel, I'm going to write it in this little margin up here. K1 is parallel to K3, all right, because they have the same slope. So parallel slope means the two lines have equal slopes. So I'm going to give you a minute to do the guided practice, number 3, and then you can come back and check with me to see what my answer was and compare it to yours. All right, so with this guided practice, it is simply just taking the slope formula, finding the slope of each line, and then comparing. Are the two lines parallel? Well, I get for the first line the slope of line C being 9/4, and then I could simplify -12/4, but mainly what I care about in this example is understanding that the slopes are not identical, so the lines are not parallel. So that's the main thing to get from that example, from that guided practice. So we're going to move ahead to talking about perpendicular slopes. So we're given a line passes through 2 points, and we want to graph the line perpendicular to that line that passes through the point 2, 5. So I am first going to graph my line. So 1, 2, and then 5, 6. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. I'm going to draw my line. And it has to pass through the point 2, 5. So 1, 2, 1, 2, 3, 4, 5. So we want a line that is perpendicular to this line, passing through the given point. Okay, so what I'd want to find first is the slope of line H. So the slope of line H, 6 minus 2 over 5 minus 1. So 6 minus 2 is 4. 5 minus 1 is 4. The slope of line H is just 1. So the perpendicular slope is the opposite reciprocal. So the opposite sign of +1 is negative, and the reciprocal of 1 over 1 is, if we flip the fraction 1 over 1, it remains 1 over 1. So our perpendicular slope is -1. So from our given point here, I'm going to count a slope of -1. So down 1, right 1. Down 1, right 1. And then I can draw my line. And this should look like it crosses at a 90-degree angle. So perpendicular slope is the opposite reciprocal. Opposite sign, write your original slope as a fraction and flip that fraction. Swap the numerator and the denominator. Example 4 is a good example of using slopes in a situation or a context. So it talks about a truck driver making 3 deliveries. The graph shows the trucker's distance to the destination from the starting time to the arrival time for each delivery. So using the slopes to make different statements, I'm going to talk about trip A. Trip A, it took 3 hours to travel 150 miles. So this guy traveled 150 miles in 3 hours, meaning his average speed for that trip was about 50 miles per hour. For delivery B, our driver, think about change in X, change in Y, traveled 250 miles in 3 hours. So between A and B, his deliveries, or her deliveries, took the same amount of time, but one delivery trip was longer. So 250 divided by 3 is about roughly 83.3 miles per hour. So he was traveling a little bit faster. It was a little bit quicker, right? And then the final delivery C, traveled at 250 miles, same as B, but traveled that in 5 hours. So his average speed, or her average speed for that trip, that delivery, was 50 miles per hour. So really what I'm trying to get at here is using a graph to compare rates of travel so that you can tell which delivery did he travel the fastest. I'd say delivery B. He covered the most amount of time relative to covered the longest distance relative to the shortest time, right? So rates of change is what I'm trying to get you to think about slopes as a rate of change. The change in the Y value, miles, over the change in the X value, time. So in this guided practice, I'd like you to work through those and then double check your answers with me. So a good chance for you to pause the video, work through them, and then I will explain them. Okay, so to explain the guided practice, in number 4, I kind of explained that in example 4, but it still is important to know delivery B, the driver had the fastest rate of traveled at that average speed of 83.3 miles per hour. So you're thinking about comparing, the amount of distance versus the amount of time. So that driver traveled 250 miles in only 3 hours. So an average speed of about 83.3 miles per hour, which is pretty insane if you ask me. 83.3 miles per hour is pretty fast. So that may have been a little faster than a realistic situation, but if we think about distance to the destination from the starting time to the arrival time, so realistically 83 miles per hour might be a little high, but it's just more comparing those rates of change. Okay, so now you can move on to the practice with slopes, and that is going to help you in the next lesson of graphing and writing equations of lines. Slope is big in that.